Alright, so we are doing, you want to do both of them? 8 and 9? Yeah, the synthetic division doesn't take too long. So we're going to do 8, and this is problem set what? 15? Is that what you said?
Problem.
Okay, problem set 15, number 8. And, oh, I didn't bring my good microphone for this thing. So the computer mic, it works, but it's a little bit, it's just not real nice. Oh, it's 22x, isn't it? And then plus 8. And we're dividing that by negative x plus 4. Alright. Yeah, that's a little tricky. That is a little tricky. I'll tell you what we need to do. We don't want this to be a negative. Yeah, this one is a little bit harder than one I did. The one I did for you guys last time was pretty straightforward. This one's a little bit of a trick, so I could see where you mess up a little bit here. So when we do that little synthetic division thing, we don't want this to be negative. We want it to be a positive. So what we're going to do is we're going to factor out a negative from both of these. Let's say this. We're going to divide everything by a negative. Right? It's kind of the same thing, but we'll divide everything by a negative. So let's rewrite this. So if, I'll tell you what, let's write it as a long division problem. Is that all right? So I'm going to divide the top and the bottom by a negative. And I can do that. If I take out a negative from the top and bottom, I'm allowed to do that. So what's going to happen to this? If I divide everything on the bottom by a negative, I get an x minus 4. But I'm going to have to do the same thing to the top. So basically, all I'm doing is just changing all the signs. So it's going to be minus 3x cubed plus 7x squared plus 22x minus 8. And it's the same thing. Right? If I did that to the top and the bottom, it's the same thing. Now I can do my synthetic division because now the coefficient, remember, in order to do synthetic division, you must have a 1 in front, a positive 1. Right?
So for the second one, we would just divide the 2 into everything?
Exactly. Divide everything by 2, and then you're good to go. Yeah? So let's just do this really quick. So remember we made that little symbol like this. And what do we put in here?
Positive 4.
Right, we put a positive 4, because remember, what you put in there is that x, or that h, I'm sorry, it's x minus whatever the h is, and the h in this case would be the 4, so you put a 4 here. And then you just put the coefficients. Make sure, here's something that they may do, it doesn't look like they do it on either one of these problems, they may leave out like an x squared, you follow me? So you have to fill it in with a 0. So always make sure, if you start with a cube, you have to have a squared, then an x to the first, and then a constant, right? So that'll be, and we do, so we can just put our numbers in, and we can do that. All right? Now, we drop this first one straight down below the line, and then we multiply. We multiply, we get negative 12, and then we add up the columns, which would be a negative 5. Multiply again, which would be a negative 20. Add them up, that's a 2. Multiply again, that's a positive 8. Add them up, that's a 0. Right? So that's your what?
That's my remainder.
That's your remainder. This is your constant. This is your x, and this would be your x squared. So it would be negative 3x squared minus 5x plus 2, and that's it. All right? If you wanted to, it's a little time consuming, but if you wanted to, you could take this to check it and multiply it by this, and your answer should be this. Okay, a lot of this is in it. Okay? Does that make sense?
Mm-hmm.
Alright. But, you know, if you don't want to, you don't have to.
I think that's the only problems I have.
I love that synthetic division, don't you? Did you get lost on? Did you get lost? Forgot what room we're in? Alright, let's do this one real quick. Negative 8x cubed. Plus 2x squared plus x plus 2. Alright, now remember, we can't have a 2 out front, so we have to get rid of it. And how do we do that? We divide everything by a 2. Even over here, we divide these by 2 as well. Alright? So what are you going to get then? You're going to get an x plus 1/2. And then what's that going to be? Negative 4x cubed plus 1x squared plus, now you could write it x over 2, but I like to write it as a coefficient, because for our synthetic division, we're going to use the coefficient. So that's the same as 1/2 x, and that's plus 1. Now we have fractions, but it's the same deal, right? Do that little box thing. What goes in here? -5? Or do you say, what'd you say? Did you say half? Oh, okay. I thought you said 5. I didn't. It's all those cars outside. All right, so it's -1/2. You're right. And then you put the coefficients: -4, then a 1, then a 1/2, and then a 1. And then see what we do here. Bring this down. It's -4. So negative times negative is positive. Half of 4 is 2. Add them up. That's a 3. That's going to be what? -3/2, isn't it? You multiply them together. You add those up. That's -2/2. But what's -2/2? It's -1. Then you multiply again. That's +1/2. We do get a remainder this time, don't we? And that's 1.5, or let's write it as 3/2. Is that all right? Because 1 is the same as 2/2. Did I do my math right? I think I did, didn't I? +1 times that. Yeah, looks like everything's right. And then there we go. That's our remainder. That's our constant. That's our x, and that's our x squared. So it's -4x squared plus 3x minus 1. And then our remainder is this. How do we write a remainder? We don't write the r. That's like in elementary school. We put plus what? 3/2 over whatever we were dividing by, right? So what were we dividing by? X plus 1/2. They may write it like this. They may simplify the fractions. My guess is they probably write it like this. Do you have the answer in front of you? Or let me check the answer. Okay, they don't leave it like that. They do simplify this thing right here, right? So how in the world would you do that? Well, I'm going to put 3/2 over. Now we have to simplify that. It's x over 1 plus 1/2. So it means you have to find a common denominator. All right, so the denominator is 2. It's just 2 because it's a 1 and a 2, right? And then so if I make this a 2, what am I going to have to do with that? Make that a 2x. So it's going to be 2x over 2. Isn't that the same as just x? No, and then plus 1, right? And then we could do this. Do you remember division is the same thing as multiplying by the reciprocal? All right, so I'm going to take the top one. Instead of dividing by the bottom, I'm going to multiply by the reciprocal of the bottom. So it's going to be 2 over 2x plus 1. Am I doing this right? Yeah, that's right. Yeah, yeah. Yep, the 2's cancel out, and so you're left with 3 over 2x plus 1. So that's your remainder. What's that? They didn't?
No.
Okay. And that's how they do that. I don't know. Oh, you know what they do? You know what? I was dumb. You know what? You didn't even have to go through all that because I put it over this. Let's see, but the thing is, oh, I know why they do it, because they don't do synthetic division. They're not doing synthetic division, so they're not going to have this thing that you're dividing by. I think they call that the divisor. They're not going to have a half, because they didn't do that. They did regular long division, so they actually do put it over this. All right, so their remainder will be just a regular 3, and they're going to put it over this, so they wouldn't have to go through that mess. So that's definitely one little disadvantage of doing synthetic division was, yeah, you're going to have to take this and simplify it to that. Does that make sense? Okay. All right, what else we got? All right, so let's just mess around with this calculator just to show you how nice and clean. And that's basically the only reason I like this is because it's clean, it's pretty, and it's just makes it easy. So what do we got? Y equals, I read it off to me so I don't have to keep looking. It's x to the fifth.
X to the 5th minus 3x to the 4th.
Minus, okay, hold on. 3x to the 4th, okay.
Minus 2x to the 3rd.
2x to the 3rd, okay.
Plus 5x to the 2nd.
Plus 5x to the 2nd, okay.
Plus 2x.
Plus 2x.
Plus 4.
Plus 4. Does that look right? Okay, and then you say plot, and oh, there it is. Isn't that pretty? And then you can just, yeah, you just compare it to your thing. And if you're doing these at home, you know, you got your computer right there. It just makes it real nice and easy. But you guys don't even have the graphic calculators anyway, right? So you're going to have to use computer anyway, no matter what, you know, calculator that you use. And here it is. Now, it was x to the 5th. Do you remember what he talked about, how many terms there are? There should be how many terms if it's x to the 5th?
Oh, there should be 4 turning points.
Right, there's turning points. There should be one less than what the highest exponent is. And are there? 1, 2.
And then the dip up there.
Is there another one up here?
The dip. Like where it goes down.
Oh, yeah, I didn't even count
1,
that.
2,
So 1,
3,
2,
4.
3, 4. Right. For some reason I wasn't seeing that. Right, 1, and then down, 2, then up, 3, and then down, 4. Yep. And so there you go. All right. What else?
Another thing I had trouble with.
Okay. So we're trying to find the zeros of this. So what we're going to do is take the factors of the first coefficient and the very last one. So that would be, and let's see, what was it? That was like, or wasn't it like we put 2, the numerator could be either a 1 or a 2, and then the denominator is what, 1, 2, 3, and 6, correct? Plus or minus? Yeah. So let's just do this. So we could have 1 over 1 and 2 over 1, right? So they're the easiest numbers to pick. So let's just try one. We're going to see if any of these numbers, excuse me, we're going to see if any of these numbers make this thing a 0, and that's going to be one of our factors. Once we know one of our factors, we can do the division to find the other factors. Sorry. All right, so let's just try a number. Let's put a 1 in here. So 1 cubed is 1 times 2 is 2. 1 squared is 1, and that's a minus 6. That's a 1, and that's a plus 6. Let's see what we get. We get negative 4 plus 7. Nope, that's not going to give you a 0, so that's not going to work, is it? So 1's not going to work. Let's try a 2. Put a 2 in for x. 2 cubed is 8 times 2 is 16. Put a 2 in for this. 2 squared is 4 times 6 is negative 24. Put a 2 in for this, and then let's see. I don't think that's going to be a 0 either, is it? Or no, maybe it is. That's negative 8, isn't it? Isn't that negative 8? Okay, and then plus 8. Ah, look at that. Yay, us. We got it. Okay, so that was nice. We didn't have to throw fractions in there. That'd be kind of ugly, wouldn't it? My guess is, I don't think he's really putting any problems on here where you're going to get these weird, crazy factors. So they're probably going to be either positive or negative numbers. Now, we could have put a negative one in there as well to see if that would have worked. But the 2 worked, didn't it? So what does that mean? That means x minus 2 is going to be one of my factors here. Because remember, x minus 2 equals 0, added 2, so x equals 2. So that means if I put a 2 in here, that makes that thing into a 0. Does that make sense? So that's going to be one of my factors. But I got to figure out, put a question mark right there. I got to figure out what this is going to be. How do I figure out what that's going to be? Well, I'll take the x minus 2, divide this whole thing by x minus 2, and that's what this is going to be right here. Okay? So I find one of the factors, I divide this by one of the factors, and I figure out what my other factor is going to be. So that's what I'm going to do. And that's why we did that division, that, what do you call it? Synthetic division. So let's do it. So we've got x minus 2, and we want to go 2x cubed minus 6x squared plus x plus 6. And then we do our synthetic division. And this is real nice because our coefficient isn't 1, right? So we're good. We don't have to divide anything like we did earlier. So we just write it out. So what's in that little box right here? Just a 2. What's going to be inside of this? All the coefficients. So it's a 2, it's a negative 6, it's a 1, and then it's a 6. And now we can do our division. Bring this down, multiply, then we add them up. Then we multiply, then we add them up. Then we multiply, and we add them up. And that's nice that we get a remainder of 0, because that would be pretty ugly to use as one of our factors. So that's going to be our remainder, our constant, our x, and our x squared. So we had a question mark here, but now we know what's going to go in there, don't we? This is going to be 2x squared minus 2x minus 3. You with me? And what was the question again? Find the zeros?
Yeah.
Okay, so this is all going to be equal to 0. So what we want to do, let's move this down here. I have some room to work. Put that right there. So now what we do is we find the zeros. So we go x minus 2 equals 0. We already knew that from the beginning, that x was going to equal 2, didn't we? All right, so that's one of our zeros. Now, what are we going to have to do? We're going to have to take this, and we're going to have to set that equal to 0, and then solve for x. You could try and see if it factors, all right, and that would be all right. You could do that if you wanted to. But what if it doesn't factor real nice and pretty? You'd be sitting there all day trying to figure out what works. If I have something that you can't figure out maybe right away, I would use what? We talked about it last week. Quadratic formula, yeah. And you want to do that instead of factoring? This could factor, and it very well may factor, okay? But if you're not sure if it factors, instead of taking 10 minutes and trying different things that makes it factor, go ahead and just do the quadratic formula. So it's negative b, so b is negative 2, right? So the opposite of negative 2 is 2, plus or minus the square root of b squared. It's negative 2 squared, which is 4, minus 4ac. So it's 4 times 2 times c, which is negative 3. And the whole thing is over 2a. I know I'm going kind of fast, but you could always look at it right on YouTube and pause it and go back and try it yourself. So we've got 2 plus or minus the square root. This is going to be 4. 2 negatives, that's plus, and that's 4 and 6, that's 24, right, over 4. And so let's keep going. That's 28. So this didn't come out real nice and pretty, did it? So it probably did not factor. Let's simplify it, though. It's 2 plus or minus. Let's take the square root of 8. What times 8 is 28 that will give us a nice whole number? Nah, there's something else. 7. 7 times 4, right? So this is 4 times 7, wouldn't you agree? So what's the square root of 4? 2, so it's 2 square root of 7. And the reason I did that is because I can simplify this. You see that? So 2 goes into everything. 2 goes into this once, 2 goes into that once, oops, once, 2 goes into this twice. So what is our final answer for x? It's 1 plus or minus the square root of 7 over 2. I would have never come up with that on factoring, would you? No, I would have never thought of that. Is that one of our answers?
Looks like
I sure hope it is. What number were we doing anyway?
Number 22.
22. All right,
So
is that one of ours?
D.
D? 1 minus and 1 plus. Yep, that's exactly right. And so those are our factors, and D is the choice. All right? Okay, so we're jumping to Prom Set 19 now. And we're looking at, let's just do the easiest one first, okay? Then we'll move on from there. We'll just do number 5. And it says, now this book loves to put, this guy loves to put f of x or g of x, but remember you can always replace that with y. And he says that too many times to remind you. Okay, the vertical asymptote is what you want to find, correct? So the vertical asymptote means what value for x cannot exist. All right, because if you have a rational function, which means you have a fraction on the, or you have a fraction, and you're trying to graph a fraction basically, especially if you have x on the bottom, you are restricted. Okay, you can't put any single number that you want in for x. What can the whole denominator not equal? What can it never equal? It can never equal 0, right? So what are we going to do? We're going to take 4 minus x, and I like to put not equal 0. So what can the denominator not do? It cannot equal 0. So I want to find what my x cannot equal.
So 4.
Okay? So x cannot equal 4. That's right. So, just add an x to both sides, and x cannot equal 4. So what does that mean? That means 1, 2, 3, 4. When x equals 4, is there a y value associated with it?
Yeah.
Like if I did a little chart right here. Right? Remember doing this, right?
Mm-hmm.
If I put in a 4 for x, what's my y going to be? It's going to be 2 over 0. But what's 2 over 0? It's not 0. That's the whole idea of this vertical asymptote. So once you get that cleared up, then I think it'll make a little more sense. It's not over 0. It's what? What's your other choice? It's not 2. No?
I'm not sure.
You can't divide by 0. It doesn't exist, right? You're not allowed to divide by 0. For instance, watch this. Let me do this real quick. It's not even, it's just, it doesn't exist. It's undefined, all right? So let's do this. I just want to, I'll just do that for you. Pick any number that you want, 5. Divide it by 0. Look what happens. You get an error. It even tells you why there's an error, because you divided by 0. You're not allowed to divide by 0. Right? Let me do this super quick. I know we're running up late on time, but I think it's important for you to understand why you cannot divide by 0. Like if you had 12 divided by 3, I think I might have gone over this with you earlier. What's 12 divided by 3? It's 4, isn't it? What's 4 times 3?
12.
It's 12. That's how you can always check to see if that works. You follow me?
Oh, I remember that.
Remember that? Yeah. Like 5 divided by 1 is what? It's 5. Check it. 5 times 1 is 5. Yep, that checks. What about 0? What about 0 divided by 3? 0 divided by 3 is 0. Check it. 0 times 3 is what? 0. That checks. That works. Okay? But what if you had 5 divided by 0? Now you said originally that it was 0. Let's check it. Is 0 times 0 5? No, it doesn't work. Is there any number that I could put right here that if I multiply by 0, I'm going to get an answer of 5?
Nope.
There's not. There's no number that exists. So the vertical asymptote is this. It's what value for x makes this thing not exist. Well, 4 does, doesn't it? Okay, if I put a 4 right here, 4 minus 4 is 0. 2 divided by 0 doesn't exist. Right? So at x equals 4, that does not exist. That's why we put the dotted line right here. Does that make sense? So there is no value. You can't put like a point right here. Your graph cannot go through the dotted line because it does not exist. You get that? So that's what they're talking about, the vertical asymptote. So how do you find the vertical asymptote? You take the denominator, you set it equal to 0, or you set it not equal to 0, however you want to look at it. All right, and that'll tell you what the vertical asymptote is. Okay? Now, sometimes you have 2 of them. For instance, like number 6. Let's do this in a different color. So I've got y equals x minus 1 over 2x plus 1 times x minus 5. All right, so look at this. You actually have 2 things that x cannot equal. Remember what you're going to do? You're going to take both of these things. See, they're multiplied together. So you're going to take them both and set them equal to 0. So 2x plus 1. Because if this thing right here was equal to 0, it didn't matter what this number was. Anything times 0 is 0. Would you agree? So we're going to take both of them. We're going to set them equal to 0. So if you do this, subtract 1, divide by 2, so that's negative 1/2. And then you add a 5, so x is 5. That means, where are your vertical asymptotes? At 5 and negative, if that's 1, we'll say negative 1/2 is right there. Okay? So then your vertical asymptotes would go like this. Okay?
And then for number 7, would I just factor
Then you would
the
factor
bottom?
it, exactly right. Okay, because what you would do for number 7, you would take x squared minus x minus 2, and then you would set that equal to 0, and then you would factor it. Yeah, absolutely. Now, if you're if it was a real weird thing and you couldn't factor it, then I guess you could put it into the quadratic formula, find out what your x's are there. Okay. Now, if your x's came out to with an I in it, you know, because sometimes you do quadratic formula, you get an I in there, right? Well, i's don't even exist on a number line, so you just throw them out. You don't even worry about those. You just take the real number of values for that. Okay, what were you going to say?
Also, the horizontal or slant asymptotes.
Yeah. On that, he went through the whole thing where, like, if you had like this, x minus, yeah, x minus 2 to the 4th. Now, if you look at this, remember he said you could kind of throw out some of those numbers because they don't really make a big difference in the grand scheme of things. That's what we're going to do here. We're going to say, okay, this is an x cubed. Now, you could take this to the 4th power, but that would be a pain. But what would your lead coefficient, or your lead exponent be?
X to the
It'd be x to the fourth, wouldn't it? And I don't care about all that other stuff over here. I can just not worry about that. So I'm looking at this. I'm looking at x cubed over x to the fourth. And if you did that, what's that going to be? This is going to be 1 over x. You see that? So let's see. That would, when it's like this, when the smaller one, this is what he called a proper fraction. Remember improper fractions? Like 7 over 3 is an improper fraction. What would a proper fraction be? 2 over 3, where the top is smaller than the bottom. Same thing here. If this one is smaller than this one, there's a rule in there. I forget, there's some fancy name for it. There's some rule in there that says the horizontal asymptote is on the x-axis. It's y equals 0. Okay? So, like if you had this and this, then what's the horizontal asymptote? It's actually the x-axis. So it doesn't matter what the numbers are. If this is smaller than this, it's going to be along the horizontal, or it's going to be along the x-axis. That's your horizontal asymptote. Does that make sense? Okay, the one where it's a like 9. 9 would be like 2x over x plus 3. Again, we get rid of the extraneous stuff. We just look at this and this. So what's 2x over x? Well, the x's cancel out, and it's 2. Right? So it's y equals 2. So that would actually... Yeah, that would be your horizontal asymptote. So you go up to 2, and that would be your horizontal asymptote. Does that make sense? Because look, the power for this x is the same as the power for this x. And then you simplify it, and it's going to be right here. So when the top is smaller than the bottom, the horizontal asymptote is the x-axis. When they're the same, you just simplify it, and so whatever that is right there. There's another situation where, like number 10, where it's x squared minus 4x plus 1. This is the slant one, 2x minus 3. Now watch. Again, forget all this stuff. Forget all this stuff. Just look at this. This is x squared over 2x. You see it? Watch. One of these x's cancels with this x, so what is it? It's 1/2 x. Or y equals 1/2 x. Because they don't realize we're still teaching.
Why did you cross out the 4x that was next to?
Because he gives an explanation to it, is these numbers get super, super big. The x squared is so powerful that it really overrides this. This is just almost insignificant compared to how big this is going to be. All right? So it really is not going to make that much difference in the grand scheme of things as we go super, super big. All right? He does give an explanation. He goes on for a while about it, a little tedious, but that's basically what it means. So what's our asymptote here? It's this line right here, y equals 1/2 x. And what would that be? It means it'd have a y-intercept here, have a slope of 1 over 2, and then that would be your slant asymptote.
Okay.
Okay? So there's 3 different scenarios. One when the top is smaller, one when the top is bigger, and one when they're the same. All right? And so we went through all that. It's a little rushed, but we got to go now. Sorry about that.
Well, that was basically my only problems
Right.
for everything.
Again, if you have a question, email me. I don't even care if you call me. We could figure something out. You could email me the question. I could maybe email you back, or I could even do a video for you and put it up on YouTube. You could watch it. Okay? So don't think this is the only time that we have to meet. If you really get stuck on something, definitely, get in touch with me. I'm glad to help you out. Okay?